The rate of change for parametric functions can be determined fairly easily, using the idea that a parametric function can be defined as f of t equals x of t, y of t, with x of t being the horizontal component of motion and y of t being the vertical. This means that as x of t increases, there is movement to the right, and as it decreases, there is movement to the left. This is also similar to y of t. However, with y of t, when there's an increase, there is movement upwards, and as it decreases, there is movement downwards. So let's take a look at an example. Here's a table of values of a parametric function defining a particle's movement that gives us values of x and y in terms of t. It also happens to be in the shape of a circle. Recalling the relationship between the change in x of t and the particle's movement, would the particle be moving to the left or right on the interval of 0 is less than or equal to t is less than or equal to pi over 2? Feel free to pause the video for a moment while you formulate an answer. It's going to be moving to the left, and we know this because when t equals 0, x of t equals 1, and when t equals pi over 2, x of t equals 0, meaning x of t decreases over the interval, and therefore the particle would move to the left. Now, would the particle move up or down over that same interval? Feel free to pause the video for a moment while you formulate an answer. It's moving up, because over the interval, y of t is increasing. Now we can also look at finding the average rate of change of both components. This can be found with the equations x2 minus x1 over t2 minus t1 for the horizontal component of f of t. And you can find the vertical component just by replacing the x's with y's. Here is another table defining a parametric function of f of t. It will look a little something like this. Here, let's get a closer look. Here we can see the interval of t from about 3 to 5. Now what if you wanted to figure out the rate of change from one value of t to another? Well, we can use one of the equations from earlier to find it. What would be the average horizontal rate of change from t equals 1 to t equals 4? Feel free to pause the video for a moment while you formulate an answer. It would be 1, found using x2 minus x1 over t2 minus t1, which would equal 1 in this case. Now how about the average vertical rate of change over the same interval? Feel free to pause the video for a moment while you formulate an answer. That's going to be -6. Once again, using the equation y2 minus y1 over t2 minus t1, we could find that the average vertical rate of change would be -6. Now let's take a look at parametrically defining a linear function that we already know. Remember that since f of t is equal to x of t, y of t, we'll have to find both x of t and y of t to really define f of t. To define x of t and y of t, we will need at least one point that f of x travels through, and the slope of the linear function. So let's take a look at the equation y is equal to 3/4 of x plus 15 over 4. We are also given that the function passes through the point -1, 3. So now, how do we actually get x of t and y of t from this? Well, it's actually fairly simple. First, you're going to want to figure out the slope of your component, and it's pretty easy to do that. For the horizontal component slope, it's just going to be the denominator of the linear function slope, in this case being 4. The vertical component slope is then going to be the numerator of the slope of the linear function, which is 3. Now, for both components, we just add the value of the point we know that correlates to that component. In this case, we add -1 to the horizontal component and 3 to the vertical component, giving us f of t is equal to 4t minus 1, 3t plus 3. As seen earlier, we can also have parametric equations that define a circle. It's important to remember the equation for a circle, which is going to be x minus h squared plus y minus k squared equals r squared. It will also be important to note that x of t is equal to r times cosine of theta, and y of t is equal to r times sine of theta, where r is equal to the radius of the circle. This means that the parametric equation for a circle centered around point hk would be f of t is equal to r cosine of t plus h, r sine of t plus k. Using the equation f of x is equal to x minus 2 squared plus y plus 4 squared equals 4, let's find the parametric equation g of t of f of t. We know h equals 2, and k equals -4, and r equals 2 because of the equation given to us. This means that the parametric equation g of t is going to be equal to 2 cosine of t plus 2 sine of t minus 4. Hopefully this video helped you understand parametric functions a little bit better. I hope you have a great rest of your day.